Hello and welcome to Animated Education. Today we are going to continue talking about derivatives. So in addition to sum and difference rule, we are going to learn product rule, quotient rule, and chain rule. Okay, so let's begin with product rule. Product rule basically says that if we have two functions, f of x and g of x, and these functions are multiplied, and we want to find a derivative of this common function, we get that we need to take a derivative of a first function, multiply it by the second function, and add a product of a first function and a derivative of a second function. Okay, so let's begin with an example. Let's say we have a function m of x that is equal to 3 times x squared times sinus x. Okay, so this 3 is a constant, and this constant is multiplied to a function, so we can simply take it out, then calculating a derivative. This is our f of x, and this is our g of x. So let's try to find a derivative. So a derivative is equal to 3 times a derivative of a product of these two functions. So we get that, maybe let me write another line. Okay, so we get that it's 3 times a derivative of x squared times sine of x plus x squared times a derivative of sine of x. Now this is equal to 3 times, you already know what the derivative of x squared is, it's 2x times sine of x plus x squared times a derivative of sine of x, and you already know it, it's cosine of x. So now we need to multiply everything in our parentheses to the 3, and we get that our answer is 6x times sine of x plus 3 times x squared times cosine of x. This is our answer. Now let's talk about quotient rule. Quotient rule says that if we have a function f of x divided by the function of g of x, and we want to take a derivative of this, we get that f prime of x times g of x minus, that's a big difference, okay, from the product rule, f of x times g prime of x, and this is all divided by g squared of x. So two big differences, minus here instead of a plus, and we have g squared in the derivative, in the denominator. Okay, so let's move on to an example. Let's say we have x cubed divided by sine of x, and we want to take a derivative of it. So we get that x squared prime, it means that's a derivative, times sine of x minus x cubed times a derivative of sine of x, and it is divided by a square of sine of x. Now we need to find a derivative of x cubed. That will be 3x squared times sine of x minus x cubed times cosine of x, okay? And it is divided by sine of x. That is our answer. You could try to simplify that, but all you would get would be taking x squared before parentheses, and that leads to nowhere, okay? So there is no point in doing that. Okay, now let's talk about chain rule. Chain rule. This is probably one of the most important rules, and it's different from sum rule, difference rule, product and quotient rules, okay? So it's used for functions, for composite functions, and these functions basically is two functions that one function depends on the other function. Okay, so here's how it looks like. So d divided over dx, that's a sign that it's derivative. It would be the same if I just wrote prime instead of it, okay? So a derivative of x of f of g of x, okay? And what chain rule says that in order to calculate a derivative of such function, we need to take a derivative of first function as it is and multiply it by the derivative of the function that is inside our first function. So a derivative of g of x. Now this looks overly complicated, I agree with you, and it's easier to simply show an example. So let's say we have sine of 2x, okay? And we want to calculate a derivative of it. So one function, here is two functions, okay? One function is f of x is equal to sine of x, and the other function is g of x, and this is 2x, okay? So you need to notice this and know that the derivatives provided in that table that I gave you in the last tutorial is only for the functions that was in that table. If anything is changed in that function, we need to apply a chain rule. So here's what we get. We get that we take a derivative of sine of 2x and we get cosine of 2x and multiply it by the derivative of 2x, and we get that this will be 2, so we get that our answer is 2 times cosine of 2x. Now there is one other way you can look at it, so, and I actually prefer it to look at it that way. I did it when I was learning derivatives. So you can see that 2x, we are calculating the same derivative, that 2x is equal to, let's say, a. So now what we write? We write that sine of 2x derivative is equal to derivative of sine of a multiplied by the derivative of a. Now we get that sine of a would give us cosine of a multiplied by the derivative of a, and that is a derivative of 2x. And now we get that it's 2 cosine, we change a to 2x here, so here's our answer. You can freely choose which way to solve these equations, to find in which way to find the derivative. They are equivalent and they are both right. So now I'm going to provide you with 10 examples of finding derivatives of composite functions. So yeah, here we go. So now, first example, f of x is equal to x minus 1 times x plus 1. So you could apply product rule here, but it's not really helpful because it would consume time, and that's completely not necessary. We can rewrite this as x squared minus 1. That's what you would get if you multiplied x by both members and minus 1 by both members. Or you can simply apply a formula here. So a formula would look like that: a minus b, a plus b is equal to a squared minus b squared. And here's what I did. So now this is not a composite function, but it's very useful to know that you can change these functions so they would be easier to calculate a derivative of. So our derivative of this function would be 2x, just 2x actually, because this will give us 0. Okay, so yeah, that's our answer. Okay, now a composite function for real. Okay, so y is equal to sine square of x. Now I wrote here y because it's just faster, but it is equivalent to write y or f of x, because f of x, basically this will give us a value of y. Okay, so you can write either of them. So now y prime is equal to, now we need to apply a chain rule. So we get that at first we look at this whole function as x squared, okay, some variable square, and we get that 2 sine of x multiplied by sine of x, and we need to find the derivative of it. This will give us 2 times sine of x times cosine of x. And we actually can apply a formula of trigonometry identities. So this would give us sine of 2x, but that's not necessary. If you don't remember this identity, it's not necessary. But it's a nice way to write an answer, okay? Okay, so for those who this wasn't clear, I just write it one more time. Okay, so you can calculate this function like that, a derivative of this function like that. You can say that u is equal to sine of x. Now our function will be u squared. So a derivative of that function is derivative of u squared times a derivative of u, and this will give us 2 times u times a derivative of u, and u is sine of x, so it will be cosine of x, and we need to place a u value here, and we get that our u is equal to 2 times cosine of x times sine of x. And we could write our answer in the same manner if we like. Okay, so I hope first or other way was clear to you. Okay, so here's the function, a square root of sine of x. Now, in order to find the derivative, first we need to to look at this as a function of a square root of x, and that will give us 1 over 2 square roots of sine of x, and we need to multiply it by a derivative of sine of x, and this will give us cosine of x divided by 2 square roots of sine of x. Okay, so let's say we have a function y is equal to sine of 2x square. Now, this is a composite function of three functions, okay? There is three functions here. You need to know that and notice that. So now we'll need to apply chain rule twice, okay? So here's what we get. First, let's look at it as x squared. So we get that this will give us sine of 2x times a derivative of sine of 2x. Now, this is a composite function again, so we need to use chain rule again. I'll rewrite sine of 2x times. Now, look at this as a function of sine, and this will give us cosine of 2x times a derivative of 2x. And our answer is 2 times sine of 2x times cosine of 2x. And again, we can use trigonometry identities to simplify this, and this would give us sine of 4x. But again, this is not necessary, but it's a nice way to write an answer. Okay, so let's say we have y is equal to 3 to the power of x squared. So, a derivative of it would be 3x squared times natural log of 3. I'm looking at this as simply exponential function, and we need to multiply it by a derivative of x squared. So this will give us that 3 to the power of x squared times natural log of 3 times 2x. Here's our answer. Let's say y is equal to natural log of a square root of sine of x. Now, our square root of sine of x can't be less than 0. So we'll have real solutions only if x is somewhere between 2p times k and p plus 2p times k, where k is any real number. I forgot to write this in previous examples. Then we had a similar function, but it doesn't change the way you calculate derivatives. It's simply mathematical correct to write when our solutions are real and when this is true, okay? So, but it doesn't change how we calculate derivatives. So it doesn't change the idea of this lesson, okay? Okay, so let's calculate this derivative. Okay, so there are three functions here. Natural log of sine of something and a square root and sine of x. So let's change our variables here, okay? Let's do that just for the sake of this tutorial, and so you would know what to do if you have three functions, not two. So let's say our u is equal to a square root of sine of x, and our a is equal to sine of x. So this becomes a derivative of natural log of u times a derivative of u. A derivative of natural log of u is 1 over u times a derivative of u, a derivative of a square root of a. Okay, so let's leave this 1 over u for now and just rewrite it So now a square root of some number is a derivative of that is 1 over 2 square roots of that times a derivative of a. Now a derivative of a will be cosine of x, and here's what we get. We get 1 over a square root of sine of x times 1 over 2 square roots of sine of x times cosine x. Now we need to simplify this. I wouldn't recommend leaving it like that. This looks very not pretty. Okay, so let's multiply these square roots, and that will give us 2 sine of x multiplied by cosine of x, and cosine of x divided by sine of x is cotangent of x. Cotangent of x. Now this answer looks a lot more pretty. Let's say y is equal to 7 to the power of x plus 1 plus a natural log of x plus 1. So here we'll need to apply some rule and also a chain rule here, okay? And I also would recommend to say that x is more than minus 1. So we could apply a chain rule here also, but it would be easier to simply say that this is 7 to the power of x divided by, multiplied by 7, because it's a plus here, and plus natural log of x plus 1. Now we can find the derivative, and it would be 7 to the power of x times a natural log of 7 times 7 plus 1 over x plus 1. We are looking at this as a natural log of u or x or something, but I wouldn't recommend saying of x because we have x here. Okay, so and we need to find the derivative of x plus 1, and this will be 1, so our answer would be 7 to the power of x times natural log of 7 times 7 plus 1 over x plus 1. Now we could use properties of logarithms and put this 7 up here, but that's not necessary. Okay, so let's say we have y is equal to natural log of cosine of x square. This is again free functions. Okay, so we need to apply chain rule twice. Now I won't change our variables. So this will give us 1 over cosine square of x times cosine square of x. We need to take a derivative of it, and we get that we simply rewrite our first member times this will give us 2 times cosine of x times a derivative of cosine of x. A derivative of cosine of x is minus sine of x, so minus 2 cosine of x divided by cosine of x square times sine of x. I put minus here, you see. So now it would be not very smart not to simplify this, as it's very obvious that we can divide these, and this leaves us with minus 2 sine of x over cosine of x, and this is minus 2 tangent of x. that's our answer. Let's say y is equal to 2 to the power of x plus 2 divided by natural log of 2 plus 4 to the power of x divided by natural log of 4 plus 5. So this is a composite function, but we can change it not to be, and I would always recommend to do it if it's possible, because if you do so, your calculation will be easier. You'll find the derivative easier. Okay, so let's change it, and this plus 2 will give us 2 times 2 times 2 to the power of x divided by natural log of 2, and we need to find the derivative of it, plus, now we can simplify the derivative of it. It will be 4 to the power of x times a natural log of 4 divided by natural log of 4, plus this will give us 0, so I just write it, and we get that this gives us 4 divided by natural log of 2 times 2 to the power of x times natural log of 2. You see, I just rewrote all of this because this is a constant and it's multiplied to the function, so we can simply take it out of our derivative, and we need just to rewrite this. These will obviously cancel out, and so we elected this. Also these cancel out, and our answer becomes 4 to the power of 2x plus 4 to the power of x. Here's our answer. Okay, last example. Y is equal to a square root of e to the power of x, where e is a base of a natural log. So a derivative is equal to 1 over 2 square roots of e to the power of x times a derivative of e to the power of x, and this is equal to e to the power of x, so our answer looks like this. You could actually simplify it, and you would get that this is equal to a square root of x divided a square root of e to the power of x divided by 2. So yeah, that's about it for this lesson. In these tutorials that I called Math for Physics, I assume that you are already familiar with mathematical concepts that I talk about. Therefore, I just solve a bunch of examples to remind you it. However, I did an exception with calculus, and I tried to make it understandable for complete beginners. Although I left some unnecessary concepts, such as an equation of a tangent line, because we won't need it in physics lessons. Therefore, if you are really a complete beginner in calculus, you're just familiarizing yourself with derivatives, I would highly recommend you to solve more examples. Derivatives is a completely different concept than anything you have learned before. It's completely different from linear algebra. So here is some problems that you can work on your own. You can check yourself using Wolfram Alpha. I highly recommend that program. It is completely free, and it's correct and it's easy to use. So yeah, for those wondering if I'm sponsored, I'm clearly not. You can look at my 0 subscribers right now. Okay, so yeah, that's about it for this lesson. In the next video, I'll continue talking about calculus, about derivatives. I'll show you how to find maximum and minimum points of a function, and that will be very useful in physics. And I'll also show you how that will be useful in physics by solving one really complicated example of how to do it. Okay, I hope to see you next time.